Okay, thank you very much, everybody. I'm very glad to present you what we're doing from the wood industry side. My name is Hansueli Schmid. I work for Lignum, that's the Swiss Wood Association. And we are also part of CEI BOIS. This is the European Wood Industry Association. So what we heard before is that planning is developing from 2D to 3D to BIM models with additional information. And yeah, the basis of all that is product information. So that means without information, the BIM is not working like it should. It helps us to build better in relation to all basic requirements in construction. Those basic requirements are described, as you said before, in the construction product regulation. And the building model helps us to make optimization cycles, so to make analysis, correction, and comparing different solutions. It helps us also to better communicate between manufacturing and trade, so the whole chain of information. And we have also more information in early planning stages. Here, especially, I would to point out that it's not always about specific products, but also generic products, because in early planning stages, planners don't want to have specific products, or they don't know the specific products. And therefore, it is certainly also a topic that we need generic information. Especially if we have, for example, not an EPD, we need generic EPDs, which we could apply if that not exists. So this is certainly an important point. And when we describe properties, we need to describe them in a common name, a common description, so that the people who use the information don't struggle with interpreting and mapping again and again. So that is a job we have to do as an association. So yeah, that's what I said. Actually, the algorithms also need clearly identifiable information, so that those algorithms which we can write today can recognize what information it is, and so our building models and algorithms really can work. It is not the problem that we don't have computers, it's not the problem that we don't have building models, and it's not the problem that we have intelligent people who can write algorithms. The problem is really the missing structured data. So we could make BIM today, we can make BIM today, but without information, it is like a mill without grain, to have another picture. And if we have unstructured information in a BIM model, it's like a mill which makes mixed flour and you cannot use it really good. So, and from the perspective of wood, we want to influence the decisions in early planning stages so that there is a switch from non-renewable to renewable materials. And wood can bring solutions in which fulfill all the requirements, actually. I run a bit over the slides. You can then later on also read the information. Now I want to give you a first overview about the project at the European Association CEI BOIS. So we started to discuss that in late 2018 and 2019. We really started to have meetings and to create a common understanding of the topic. I think that's really the most important thing when we speak, that we really understand the same thing. and that we also can describe common goals. And that needs time. That's really something that's like a new language you have to speak, and also to know what terms mean really what. So at CEI BOIS, then 4 countries decided to go further and deeper and to invest also some money to start this process of extracting properties from harmonized standards of building products in wood. This is Finland with Tommy Toratti, Sweden with Christer Green, and Austria with Christoph Eichler, and in Switzerland it's myself. And we all work for those wood association in those countries. And again, what we have today is that we have standards which are translated in many languages, that nobody is excluded, but we forgot a new participant in that thing. It is the computer, it's the algorithm. So standards are not per se translated in a machine readable format. And actually, in the future, that should be an integrative part of standardization, that at the end of a standardization process, we translate it also in a machine-readable way, so that all properties are named and defined. But the reality is that we don't have that, and the task is now on the association side to take those standards, to extract properties, and to make it machine readable. This creates certainly needs time to discussion and agreements again, and yeah, it's certainly not the ideal process. But today it is like that associations should do that thing for their product. Means also that we have a certain sovereignty over the data. If this association can decide what is important and not, this is also a way. Then we also worked with co-builders. It makes sense to work together with specialists which extracts the properties from harmonized standards in general. And here you see that if you work only with harmonized standards, that's not the full picture, but it's a good start. So we start with harmonized standards, we bring it into a template, and then it goes to the countries, we use it, and we get feedbacks. And those feedbacks have to be organized and harmonized, that we then can further how to say, complete additional properties which might be interesting for everybody. And if it's not something interesting for everybody, that stays at national level actually, or it is in the same template, but it's marked that it is a national properties. That's actually a bit the workflow. We found out how we're gonna work. And now we are thinking about how we're gonna organize that feedback process, that we can really agree on common additional properties which are not harmonized. So that was a bit the overview. And if I go a bit deeper, maybe to explain you, to make you understand also the connection of information from the raw material until the building. We have, when we provide information, we have information on different levels, from raw material to products to components, and then finally the whole building as a system. And behind those pictures, there is also information. So, for example, for the wood, the tree itself, the wood itself has already properties which are given by itself. And then we're going to process this material. We're going to separate strength classes and so on. Then we have products with additional information, but are still connected with the raw material. And then we bring together different products and make components, and also those components have then new properties like sound insulation, fire resistance, which are then very important actually for the architect, because he looks for components which fulfill those requirements he has. And then each project is different. Then we have the buildings, which actually is the job of the architect to assemble the right things. Yeah, interestingly, we started also with this construction product regulation, and this is it is actually a very good thing that we have a common understanding of what is our basic requirements, that we have can also a bit structure our work according to that. And this is actually what we did already in Switzerland all the years before. We developed state-of-the-art solutions for wood in all the different basic requirements. We before spoke about environmental impact. And those information have been always in different formats. So we had booklets, we had PDFs, we had small databases and another database, and external generic EPD data. So that was certainly not so good for the architects to work with wood, because they have to collect all this information in different sources. And then we decided to bring that on a common template database, which is still not BIM and international format, but at least it is structured data. But that's where we're coming from. So the topic is always we have requirements and performances, and the planner has requirements, and we as an industry provide the performance. And the good intermediate is are the components. So we can communicate with the planner over the components. The product is then something on the next step. Certainly, that's important. But we calculate the performances of components based on products. And the planner looks first of all for components. Another image to show you a bit how everything is organized. We have the Building Smart Data Dictionary. This is the how to say, the knot between all the classifications and standards and property description, generic property description. So that is where everything's coming together, and you can translate it from one context to the other. Then we have the standards. Then we have the association, and it's an important part which interprets the standards and make it useful. And then it comes down to the national context, where we provide solution in our national area with our partners and so on. And then we can share this data via API. This is the application programming interface. We can share this information with that interface to other softwares, but we can also share it via IFC files. IFC files can be imported directly to a CAD program. Just that you have an idea how it looks in Switzerland, we have, you see on top, you have also this component and products level. We have now also a wood species level. So those three different levels of information. And also here to see a bit the chain of information. You see here that the EPD data, how they are aggregated. So we have really different levels of information, how they are aggregated. We have a database of environmental impact of raw materials. We have then specialists who make the recipes for the materials needed for building products. And then we have the components which make the sum of the products. And at the end, we have the building. And this chain has to be structured in the same way that the data can flow. So certainly the biggest job, and it's not the nicest job, is to structure the data from PDF into spreadsheets and databases. But this is work we have to do. And it's better if we do it on where the data is coming from, and that is the manufacturing site. So it has to be done only once, and then all the other can take the structured data. Another image to show you what is closed BIM and what is open BIM. Closed BIM is, for example, if you have in your office cupboard and you put your documents in different places, but you know it without writing on it where it is. And everybody in your office knows where the information is. So this is closed BIM. And if you have then if you want that other people can access this information, you're gonna write it on the information. And this is actually the right image. This is the open BIM where you use common descriptions for a property. And the goal certainly is the right side. We want first discuss how is this property named, which property has to be separated, and then everybody can write it in the same way. You see here the structure of our database on 3 levels. And also we transformed the information in IFC in 3D models. So nobody had to design that. It was really generated automatically. And now you see the use of the API. So particle board and OSB producers with Chrono accessed our information. They use our information in their environment, and they show how their products are applied in our components. This is another image about the topic of generic specific. So we don't have to forget the generic side, that mostly we begin with generic materials and products, and by time it becomes more and more specific, but you will have always products which are generic until the end. This is another image to visualize a bit horizontal. You see generic to specific. Must be the same structure because we can have both on the same time. And we also need the same structure for the different level of assembly of materials, or material, product, component, building. We should try to use a common structure. And if I have time, then I go quick through BIM and LCA. Thank you very much. Yeah, I want to add on what you said about this construction product regulation and PEF, product and environmental footprint. This is really a pity. And we analyzed that at CEI BOIS, and we have to say that we saw that the advisor for this project is SGS, and they follow certainly a label type 1. What is label type 1? Label type 1 is a label that has to be verified by third parties. Actually, what SGS is doing, that's their business model. And in my view, that's a conflict of interest. If a company like that is is consulting the European legislation. What we have with EPD, according 15804, that's a label type 3. So it's a different label that depends really on those data which are calculated and verified by another expert, but not with another third-party institution. And that is really undermining, if it goes further to PEF, it's really undermining the whole also digital process, because we don't know then what we really need. So this is very, very important that we keep, if it comes in a harmonized way, that we really stay on EN 15804 and not PEF. PEF is like an additional label and cannot be applied. But well, we maybe all agree on that, but I wanted to stress that again. Why it is important to have EPDs in BIM? It is we have an imbalance at the moment between humans and nature. We all know that, and we have to take care about more how we use our resources, especially the non-renewable resources. We have to use more the natural resources in a sustainable way. And certainly BIM can help us with this decision-making process to decide if we use non-renewable or renewable resources. We are all humans, we have habits, and also architects have habits to build certain things in a certain manner. But maybe our friend, the algorithm here, the robot, can help us to get the real picture of how much impact the material we use has on our on our environment. And maybe this is also a way to additional analyze and optimize without too much effort. And certainly we from the wood side, we say, yeah, wood is the ideal material for that, because it's circular between technosphere and ecosphere. We can also recycle the material. And but actually it's with all materials like that, we should try to keep it as long as possible in a recycle cyclus. We see that also in politics, it becomes a topic with Mrs. von der Leyen. She was mentioning that, and it goes certainly in that way that the impact of building materials is going to be more and more important. Therefore, we want to be prepared that we can have a full picture of environmental impact, not only the use stage as it is today, but really the whole picture, whole life cycle optimization. And that creates maybe also new solutions in the form, new possibilities also for construction products. Well, I hope I gave you a short overview about what we do in the wood industry. Maybe at last I can show you that we work on the integration of EPD data in Building Smart Data Dictionary. I hope I find it now. I cannot switch it. Okay, I have to do that. So you see here in the preview, in the test environment, we have now integrated these indicators of EN 15804. That was work done by Building Smart International Product Room, and now it is there to use it in a test environment. Thank you very much.
Thank you very much, Hansueli. You're new to the CPE forum, so we are product neutral. We don't have a go at others. never mind, we'll keep that in the slide. But we all have positive and negative sides, and that's the thing. CPE is also for the whole life cycle approach. So this is something that's been said for over a decade. Just to come back to one of your slides where you mentioned essential requirements, it's an anecdote, but one that is worth noting. Some of our colleagues have reported that when they go from the paper standard into the coding version, they've actually found errors in the text, because people come in the room and they some sort of agreement and compromise, and then something that looks all right in the text, when you have to code it, it doesn't work. So it's quite funny that, and I've put the link in the comments, that CEN is now looking to digitalize its standards, and you're all invited to join in a project. And I said in the next 2-3 years, there will be no paper versions of standards anymore. It'll all be digital. But it's also a checklist of the value of the text. But that's the another.
Yeah, but it's true. It finally comes out if it's logic. If the computer can understand it, it's logic. If you cannot tell the computer, it's not logic, and then you have to rethink maybe. Yeah.
That's it. And compromise is a Belgian speciality. So there we are.